Hi, welcome to this video on my Raspberry Pi with LED play using Python versus C++. This is the RPi1 side, which uses Python for controlling the LEDs, and this is the RaspberryPi2 side, which uses C++ for controlling the LEDs. Last time it ended with the problem that although theoretically it worked that this one controls that one and that one controls that one, it turns out that some LEDs were burning which were not intended to do. So the question is why, of course. And for a start I once again removed all the, or I didn't remove them, I commented them out, all the if statements, so they are not influencing each other now. They are just running one side and one side. So let's see if they work. Starting the Python first and the C++ next. And if you watch closely, the speed with which the LEDs are changing is different, and then I mean that this speed is different than this speed. In the previous videos I have shown you that the algorithm is exactly the same. It's just a programming language that is different. However, this makes it pretty tough to have one control the other. So with all these LEDs being accessible, I'm going to stop this and to show you the oscilloscope on screen, which I introduced last time, to show if indeed all the values are shown on screen. And hopefully that works better than last time. So let's do that. And to show that everything works, I will open a new tab. And I will have to start the GPIO. Yes. Okay, I have to go to downloads and RPi Skype, and this should be working now. Okay, I should first start the daemon, which is in here. This works. Going back
and starting. Now it does work. And going to this tab, you can actually see on the GPIO of the Raspberry Pi 2 that LEDs are working. As you can see here as well, not very bright, but here you see it lighten up, and here you see it lighten up, and you can also watch it right here. The only thing that is a little bit odd is that it looks like there's only 2 lines lighting up. And what you actually should see is that one is going up and down, and then another one up and down, and that does not seem to be happening. So you see one going down and then some going up again. So that is different. So let's see how the Raspberry Pi 1 side works. Because if that is the same, that would be very, very curious indeed. Let's first start the daemon again. Okay, I have to do sudo RPi1, then to RPi scope, scope. That was the problem from last time again. It for some reason is unable to start RPi scope, which is too bad. So I can try to compile it once again. But I think that this is quite odd still. This is line 6 and it goes to line 5, and here 23, and to me this does not make sense. That's the up flank, that's the down flank. So I have to find out how this really works. Anyway, let's first get the scope on RPi1 going. My apologies for the bad quality in the first part of the screencast. I was accidentally using a different microphone. Now it should be much better. Anyway, this is the PI scope on the Raspberry Pi 1, and if you see here, you actually can see how first one is going up and then down. Here up and down, up and down, up and down, up and down again. And this is the Python version. Up and down, up and down. Now if we look at the Raspberry Pi 2 version, it doesn't make sense at all. So I definitely have to change the algorithm on this side, because I want this to happen at exactly the same way as here. Up and down before one other is going up and down. So I'm going to end scope, and I'm going to see how I can change the algorithm, because that is definitely needed. So here I set it to the LED version. This is pin 7. GPIO 4. Is this GPIO 4? Let's check this. 4 is 7. That is correct. So it waits for 2 seconds, and then I set it to 0. What I can also do to make absolutely sure that things go the way I want is comment this line out. This line. However, even though input state 31 is being read, nothing is being done with it except putting here on screen. So what I can do, avoiding confusion, let's just do that. And here as well. So let's save this. And the running of the program, compile. Because this is C++, I have to recompile, and each time I do a change. And let's see if it matters. I don't expect to, but you know, who knows. And then it is still not correct. Up flank and another down flank. So as expected, it is not saved at all. What I can do, by the way, is keep it running. And let's quit this. And check the code further. This is GPIO 4. this is GPIO 18, GPIO 5, and this is only being accessed with Ctrl C pressed, and we are not there yet, if ever. This declaration doesn't matter. So the question is, why is this happening at all? As far as I can see, this is set to 1. Here it is set then sleeping for 2 seconds, set to 0, sleeping for 2 seconds. Then it goes sequentially further with here, setting 1, sleeping for 2 seconds, so it burns for 2 seconds, then set to 0, sleeping for 2 seconds. What does the source code here do? Setting true, sleeping for 2 seconds, setting setting false, sleeping for 2 seconds, putting it on, sleeping for 2 seconds, putting it off, sleeping for 2 seconds. Exactly the same thing. So the question is, why is its behavior so completely different? And the only thing I can check out is running it again. There's nothing happening right now. Let's start it again. There we go. This makes absolutely no sense, and this is probably also the reason why the LED play is not functioning at all. So I have to focus on this side of the algorithm. A rather simple approach to solve this is to disable all but one LED. So I'm going to comment all these out. Now I have only this LED going on. Ending the run. Compiling again. And run. And also run the Pi scope, which should now only line 4 up and down. So while this is to be expected, it's nice that it does what it should do.
So ending this, and next step is to enable these again, because now we have 18, which is the second LED, and this should be in consecutive order. Oops. Will this run? I have no idea. Let's just check it out. And here is something odd. Because I have only put one other signal line open, and that's not what I see here. What I see here is 18, 23, 4 and 6. What I see here is 4, 6 is disabled, 17 is not being used, so how is this possible? Line 6, GPIO 6. Where is GPIO 6? It is not even being used. Let me go back to the various lines. 7, no, 4, 18, 5, 6 is pin 31. However, where do I put something on that? Yes, hold on, that is being influenced by, and those are the lines, of course. Those are the lines that are influenced by GPIO 1. And here I am purely reading what is on those pins. So if I ignore those lines, I should only look at the down, up and down of 4 and 18. Does that work? This is 4. Up and down. 18. Down, up and down, 4 up and down, 18 up and down, 4 up and down, 18 up and down, then 4 up and down again, 18 up and down again. Okay, so that works. So getting mixed up by the signals from RPi1 is yeah, okay, annoying, but by concentrating on the 4 and the 18 signals, I know it is working. So now I know that this is working, and I will re-enable this, which is the third LED, running and running the scope again, and this time I'm looking for so it's 4, 18 and 5. So 4 up and down, 5, which is not correct by the way, because it is first 4, then 18, then 5. 4 up, down, up, down, up, down. So that works. And I just have to ignore the other lines being influenced by the RaspberryPi1. The signals are okay. The only thing that is still bothering me is the apparent speed. Because if you look here, and I showed you that in the on camera as well, and here on the live setting, that it looks like this is going faster than this. But I still can't put my finger on the reason why. I've also been looking at the difference between Python sleep and the sleep and micro sleep, and the whole point is that sleep is for Python usual, which is in seconds, and Unix, and this is Linux, so more or less the same, and then more precise C++ and C both use microsleep, and then you have of course a million microseconds to make 1 second, so 2 million is 2 seconds, so that is all alright. Remains the question, why does the C++ run differently at a different speed than the Python? I can't answer that right now, but it is but thanks to the PI scope I know that things work the way they should, despite the very confusing signals that come from the RPi1. And I can't say anything more about that. The only thing I can do is right now is re-enable the inputs. Let's see where it gets. So and I don't do the ifs yet. I'll put them from 2. I think that's a good point to start, and then see if that works. Okay, compile. Now I have to keep in mind that this one from one side is influenced by this one from the other side. So let's check here. Oops. It's a delete action, and this is to a delete.
How did I do that? No, the ifs are still blocked. So I should leave those in correct state. Oops. Yes, that is better. So let's see what happens on this side, if anything. Well, the input states are going, but they are 0. And now it is nice to run the Pi scope. Which signals are being held in. Because here they read 31. And if 31 is only if 31 is 1, something should happen. And for the record, 31 is 6. So 6 should be happening. And this is up. So 31 is up and down, down. Let's just watch 6. That was an up and this is a down. And as you can see, despite 6 being up right here and down again, it is not displayed here. So that is a problem I have to fix. Here 6 is up again and down, but the up does not come in here. So that is definitely something to improve. But I will leave that for another time. So with some diagnostics and some clear thing to be improved, thanks to Pi scope, I just say thank you for watching and to be continued.